Guys, in this video I'm gonna build a Raspberry Pi Rover. I'm gonna name it Pi Rover, by the way. I'm just gonna connect this USB cable here to the Raspberry Pi Pico while pressing this boot cell button here. There we go. As soon as we plug that, it immediately take you here, and as this is the default page of the Raspberry Pi Pico, I'm just gonna head to Documents and go to Raspberry Pi Pico, and here we got MicroPython installed on my computer. I'm just gonna drag it to RPI-RP2. By the way, MicroPython is a Python framework that actually lets you code microcontrollers like Raspberry Pi Pico and ESP boards. And if you want to install MicroPython, I got a video on my channel on that topic. You can actually watch that video after this one. I'll put a link to it in the description box below. Okay, so now that the MicroPython is installed on my computer, I'm just gonna head to Tawny. Tawny is a code editor that lets you code in Python and MicroPython. By the way, this will be this local Python 3 will be the default option selected here when you'll install Tawny. But as I got MicroPython installed on my computer and we're programming this Raspberry Pi Pico, I'm just gonna select MicroPython Raspberry Pi Pico, and here it also says MicroPython version 1. I don't know. Okay, so now I'm just gonna wire all these. Okay guys, so I'm just gonna show you the wiring of this Pi over here. So first of all, we'll look at sensor 1, which is KY038 sound sensor. The sensor 2 is also KY038. We'll just call them sensor 1 and sensor 2 here. Okay, so this is the VCC cable of the sensor, which is connected to physical pin 40 of the Raspberry Pi Pico. Then we got this ground pin of this sensor, KY038 sound sensor, and which is sensor 1, and the ground pin of this sensor is connected to physical pin 38. Then we got this blue pin here, which is the analog pin of the sensor, which is also connected to GPIO 28 of the Raspberry Pi Pico, and which is also physical pin 34. Then we got this second sensor here. This gray wire is the VCC cable of this sensor, which is connected to pin 39 of the Raspberry Pi Pico, physical pin 39. Then we got this ground pin of the sensor, which is connected to physical pin 33. Then we got this yellow wire here, which is the analog pin of the sensor, and which is also connected to GPIO 27, and which is pin 32 of the Raspberry Pi Pico, physical pin 32. Now I'm just gonna explain the wiring of the L29810 motor driver module here. Okay, we got input 1, input 2, input 3, and input 4. Input 1 is connected to GPIO 2, which is physical pin 4. Input 3 is connected to, input 2 is connected to GPIO 3. Input 3 is connected to GPIO 4, and input 4 is connected to GPIO 5. Okay, so now so this is the positive terminal of the power supply, which is going to be provided to this L29810 motor driver module. The VCC cable of the power supply is connected to 12 volt port here, and then we got this ground cable of the power supply, which is connected to the ground port of the L298 motor driver module. But here's something different here. You may be able to see this green wire here. This green wire is going to be connected to the ground pin of this Raspberry Pi Pico, which is the physical pin 3 of the Raspberry Pi Pico. Let me just show you guys. That green cable is going to be connected here, right here. And yep, I'm just going to explain the code here. Okay, so we imported pin function from the machine library, then we imported the uTime library, which is the time library. And okay, this is sensor 1 and sensor 2. Okay, so sensor 1 is connected to GPIO 28, and sensor 2 is connected to GPIO 27. Pin.in defines that Raspberry Pi is going to get input from the sensors, and it's same here. Sensor 1 gets input gives input to pin 28 of the Raspberry Pi Pico, and sensor 2 provides input to pin 27 of the Raspberry Pi Pico. Okay. Okay, these are input 1, input 2, input 3, and input 4 of the L298 motor driver module. Okay, so this is input 1. As you can see here, it is connected to GPIO 2, and here is where we defined that Raspberry Pi Pico is going to give output to pin 2 to GPIO 2. Okay, and same here. It's gonna give him input to GPIO 2, GPIO 3, GPIO 4, and GPIO 5. Okay, so now this is a while loop. This is an infinite loop actually, because yeah, we have put a true here. Okay, so in the beginning, all the values will be 0. So like none of the motors will move at first, and then yeah, okay, so after that it's gonna be like if sensor 1 dot value double equals to 0. Yeah, okay, if sensor 1 dot value double equals to 0, which means it's if sensor 1 detects any sound, then it should say the robot is moving forward, and it's gonna give output to input 1, and input 2 is gonna be false. So input 1 is gonna be true, and input 2 is gonna be false, which means it's gonna move. The motor 1 will move forward, and then input 3 will be off, and input 4 will move forward. So both the motors will move forward, ultimately moving the robot. Okay, so and it will do the same for like the motor 1 will move forward, and motor 2 will move forward for 5 seconds, and then it's gonna turn off. Okay, after that it's like again gonna be checking if any sensor detects any sound, and if sensor 1 again detects any sound, it's just gonna repeat the same. And here is sensor 2. If sensor 2 value double equals to 0, which means if it detects any sound, so input 1 dot value is gonna be equals to 1. So motor 1 will move forward, but motor 2, because its input 3 dot value equals 1, so motor 2 will move backward. So it will like turn around and stuff. Like it will turn for a second, for 0.5 seconds, and yeah, then it's gonna stop. So guys, I'm just going to show you guys how to save this file. Now this is important because obviously the robot is not going to be connected to your computer or laptop all the time, so you'll have to power it through a power bank. And for Raspberry Pi Pico to read this file as a default, you'll have to actually save it by the name main.py. When we run the file through our computer, we have the command, we have all the control here. We can press the run button and it can just run, the file can just run, but it's not gonna be with the power bank, so you'll have to save it by the name main.py. A quick assembly of the rover. Okay, we're finally testing it. And guys, if you have any questions, please feel free to ask in the comment section below. I'll make sure to answer that, and please like the video and subscribe.